Okay, let's see our fourth exercise. Now this exercise is going to be to graph this function y equals the cotangent, the inverse of the tangent, right? X over 3 minus pi over 4. Okay. The first thing that we do, let's just chart the cotangent. Okay. It's going to be something like this. I'm sorry, the curved line. Okay, this was supposed to be straight on, but this is not going to change anything. And again, we also will have this asymptote. I'm going to use the same color. Okay. Now let's just draw. It is going to be similar to the tangent, but it's going to like to be inverse. Okay, it's going to be like this. And if I just continue the asymptote, it is never going to touch it. Okay, this is going to be pi, and this is going to be pi over 2. Now, just a small recap. I'm going to make it even in red. What is the tangent? Tangent, it is a sine of x divided by the cosine of x. And remember what is, let me just bring it here, this is a sine, yes it is. Remember the graph of the tangent. When x is 0, okay, so let's make the tangent of 0. It is going to be the sine of 0 divided by the cosine of 0. What is that? What is the cosine of 0? It is just 1, isn't it? What is the sine of 0? 0. That's why the tangent of 0 is 0. It must pass in here. Now, something different is going to happen when you're dealing about the cotangent. What is a cotangent? It is the reverse. It is the cosine of x. This should be cotangent of x, right? I didn't write. Divided by the sine of x. What is going on here now? What is the cotangent of 0? Not going to put because it's going to be a mess, okay? The cotangent of 0 is going to, let's put it down here. The cotangent of 0, it is going to be the cosine of 0 divided by the sine of 0. What is the cosine of 0? It is 1, isn't it? So far, so good. What is the sine of 0? The sine of 0 is 0. But we can't make a division by 0. Okay? So we would say that it's close to 0. Maybe, okay? And this would be 1 divided by very, 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 very tiny, tiny, tiny small amount. And the answer is going to be huge. Okay? So this is infinite. Okay? And that is why the cotangent of 0, it is up there. It's infinite. Okay? And it's never going to meet the 0 in here. Why? Because we can't have division by 0. So just in case you forget which chart is which, please, tangent, sine over cosine, tangent of 0. You know what is sine of 0. You know what it is a cosine of 0. Just do this and you can understand the chart, okay? It's no big deal. This exercise I'm going to make a little bit different. The reason why I make some exercise different than the others, because maybe you prefer one way to solve it, maybe you prefer another one, okay? And my function here, it is to show every possible way to deal with, okay? In math, you have many routes, and you don't have to choose one route, okay? So first, we are going to consider just the change in the period. Oh, I forgot. This is going to be the period change. Periods. Nothing at the amplitude because we have 1 in here, okay? Amplitude. The amplitude remains the same. And the phase we do have, okay? Amplitude multiply by 1, no big deal. The period we are going to multiply by 3. Why? Because we divide by 3 in here. And the phase, since it's a minus, then we are going to have a plus. We are going to the right, okay, because it's the opposite. Right, pi over 4. Okay. If you remember pi over 4, it is 45 degrees, right? Pi over 290, pi over 4, 45 degrees. Then we are going to move this one 45 degrees to the right, okay? So for the first case, I'm going to consider only this. Y, it is going to be the cotangent of x over 3. Just that. We are not dealing about any phase shifts yet. Okay? Now, how are we going to draw now? This means that our period will be multiplied by 3. Okay? Meaning we are just stretching, okay, like this, our chart. Or just take this like this, okay? Multiply by 3. And that means that if we had our chart like this initially, let's make it red. Okay. Now what is going to happen? Let's first put the asymptotes. Remember, everything on this chart is going to be multiplied by 3. So we don't have any phase shift so far, okay? I'm just considering this. I'm not considering the phase shift yet. Let's just see how is going to be the shape of our curve. Now, this is 0, this is 0. This is pi over 2. Then I'm going to put in here, and here. But instead of pi over 2, we are going to multiply everything by 3. Remember? So now it is going to be this one times 3. So this is going to be 3 pi over 2. Here it used to be pi, but now it must be multiplied by 3. So now this is going to be 3 pi. Okay? Our asymptote, it is going to be precisely in here. Now let's draw our chart. It's going to be the same thing, okay? Okay. It doesn't have to be perfect, okay? What it means, okay? What information does your chart have to contain? Well, this must be close to the asymptote, okay? You are just making the curve and going like this, and this is an S, okay? Kind of S shape, but in here you have to go follow this asymptote. In here, you just have to go over infinity, but never touch this axis in here. Okay, so and what happens this is 3 pi, isn't it? Look, it's 3 pi. Period, it is 3 pi. What is the period at the beginning? Just pi, right? Period equals pi. Remember? This is pi. The period was pi, now it's 3 pi. Of course it is. We are multiplying everything on the x-axis by 3, right? If you used to have pi, this width, now it must be the triple, 3 pi. If this middle way was supposed to be pi over 2, now it is going to be 3 pi over 2. Everything is a triple. But remember that this time we're going to make in steps. We did not consider yet the phase shift. Now let's consider the phase shift. Okay, and what is going on when you consider the phase shift? The phase shift. We're going to move this exactly pi over 4 to the right. Okay, so this is going to be moved pi over 4 to the right. Okay, and that's what we are going to do. We are just going to make our final charting. But, well, let's just see something first. If we're going to move pi over 4, okay, so if this is 3 pi, something like this, it is pi. Oh, pi over 4 is going to be a little bit, okay, to the right, okay? It doesn't have to be, okay, maybe in here. Yeah. The place, it does not have to be precise, as long as you just mark. I'm just trying to make as perfect as possible in here. Just like this, like this. Does not have to be perfect. What it matters, it is this, okay? The math, it is what matters, not the drawing, okay? Now, what's going to be this point? It used to be, okay, 3 pi over 2, right? But you are now moving plus pi over 4, right? So what is it left? Well, remember, everything is going to be over 4, right? So this is 3 halves, or it could be written as 6/4, right? So this is 6/4 with 1, it makes 7. 7/4, right? 7 pi over 4, this one. What about this one? This used to be 3 pi, used to, but we are now adding a pi over 4, right? We are making the phase shift now. Okay, 3 times 4, 12 with 1, 13, right? 13 pi over 4. Okay, so we can draw again. This is going to be our syntax. Can you see? It used to be in here. I'm now drawing a little bit to the right. You see? This is the phase shift. Let me just make it like this, maybe. Yeah, maybe use this pen in here. I'm just trying to relate both charts. This is precisely pi over 4, okay? I'm just moving everything, okay, to the right exactly pi over 4. Oh, one thing, okay, that we have also to accomplish. The other asymptotes I didn't write, but it was this axis in here, and the other asymptote in here is going to be this one. Okay, of course, the asymptote, it is that line that serves as a wall, so the charge never goes outside this wall. It goes like this. Oh, I'm sorry, let me see here. It goes like this, go, then move, and then go. Each time it goes lower, it comes closer, but it never touches this one. It used to be in here, the other asymptotes, but now these asymptotes, it is going to be moved another pi over 4. We have to move everything along, okay? We cannot leave anything behind. Now, these other asymptotes, it is going to be pi, because it used to be 0. It used to be right here. I didn't have to write it, okay, because it was right over the y-axis. But now that I moved everything, everything is going to be moved. And now we can see that this is just pi over 4. It used to be in here, okay? Look, these asymptotes, it was in here. And this is again precisely pi over 4. I am moving everything to the right, precisely pi over 4. I mean, it's not difficult, but it demands some attention, okay? In here. And now everything is simple. I just have to just go like this. Okay, it's done. Okay, and that's why there is no point about changing the amplitude, because okay, if you just increase the amplitude, it would go something like this, a little bit, okay. And that is the final answer. And what are we doing here? We are using the first second, using the phase shift of pi over 4. And this is the final answer, okay? And if we had to draw another one, I don't know if it is the case, but this would be the other one. The next, this is the first cycle. What would be the next cycle? And we would have another asymptote in here. Maybe it's not for you. I don't know how much your school is demanding, but... And what is the next one? The third cycle. And again, and again, and again, okay? And it's not in proportion, in scale, because I'm a terrible person to write things, okay, to draw. But this period, it must be the same, okay? Please, period. It must be exactly the same period, 3 pi. Okay? And what happens if it's not? Well, we did something in the middle that is wrong. Let's see here on this paper. Let's see. In here it was supposed to be 13 pi over 4. Let's remove pi over 4. Okay, yes, it is 12 pi over 4, which is 3 pi. Okay, I'm just taking 13 pi over 4, subtracting pi over 4 to see this width, and in fact it is 3 pi, and this is the period. You see, it is still there. And if I take 13 pi over 4 and add another 3 pi, I'm going to land in here with, I'm not going to do the math, it's not important, but this is going to be 13 pi over 4 plus 3 pi. Okay? And it goes on. And this is our chart.